So welcome to Sedimentary Structures Masterclass, and you can see here over on the right hand side we've got two images of different sedimentary structures. Have a little look, see if you can figure out what exactly we're looking at here. You can see this sort of undulating surface here. He's got a finger there for scale, and on this one here below you've got some clear lines across the surface going in this direction, and then others that go in this direction here. Okay, and some other surfaces up here which appear to be the same feature but higher up in the cliff face. So sedimentary structures, we've got some key points that I'm just going to go through very quickly, one tip, and then we'll have a look at some exam questions. So the most common type, cross-bedding, ripple marks, they are the most abundantly used in exams. So make sure you're really happy with these two. There are lots of others, but these two, if you were to if you're a betting man or woman, then you might go for these two. Primary sedimentary structures form at the time of deposition. So of all of them, graded bedding would be a classic example. For this particular one, you've got large pebbles at the, let's say, at the base, and then they progressively get smaller as we go upwards in the sequence. Now that grading is going to be the right way up for starters, but also it's formed as the energy decreases in, for example, a deep marine environment, at the end of the continental slope, where the turbidity current is losing energy. The next one here we've got is an example of actually this feature here on the right hand side. So this one, which is a load and flame type structure. Now, if you don't know what that is, do a little bit of research, but basically that is formed after or post deposition. Okay, so what we have here is key term, which is diagenesis, and it kind of does what it says on the tin. There is an increased load from above, which causes this sort of flame type structure to increase from below, and it's all to do with a difference in sediment from a sand, a coarser material, and a softer material, usually below. The sedimentary structures, all of them are absolutely linked to the environment. Okay, so your environments of deposition should form part of your revision for these. A classic example, which you'll come across, are the desiccation cracks, and if you can't remember what they are, basically they're mud cracks, and they require very placid or completely still water in dry conditions. Now that sort of environment needs to be have a high amount of evaporation, because it's got to dry or evaporate all the water away, and it's linked with salt pseudomorphs because they would be halite, which is the cubic structure which is preserved, but not with salt, with sand that's infilled the structure, so the shape remains. That's absolutely classic link between two different sedimentary structures, so always be aware of that. Many structures are way up structures as well. So if we go to the second image on the right hand side here, this one, we are looking at that cross bedding structure. We know that because scale. This is a large distance. We're talking you know, maybe 10 meters. So they are large scale structures. So they are clearly cross bedding at the result of dunes or sand dunes. Now what we can see here is a surface which is the leeward slope of the dune here, which I'm adding a few more on. Now that surface is clearly, I mean, it's curved very, very slightly like this, but that is what we would call concave upwards. Yeah, if it was concave downwards, you would have a slight curve in the other direction, so it'd be curving sort of like this. That would be the wrong way up, so ignore that one that I've just done. The first two are correct. So that would show the right way up. So let's rub those out just very quickly. The structures, all of them, or the majority of them, can be used to indicate energy levels. So they can indicate exactly what sort of movement of water, for example, is going on. So imbricate structures, if you remember, imbricate structures are structures which are pebbles, which are sort of on the side, that have been tilted over because of a paleocurrent that is going in this direction here. So that is tilting the pebbles over. So they are dipping in an upstream direction. Now that's characteristic of a flash flood or a fluvial channel deposit, so right where the water is moving at its quickest. The imbricate structures also, of course, indicate your paleocurrent, which I just mentioned. Now, paleocurrent is basically ancient current. Now, asymmetrical ripples also do this, because these asymmetrical ripples show unidirection, so one direction of the current. And of course, you should be making sure that you use a direction or a bearing to indicate that. So for example, if we take the cross bedding, which is on the right hand side here, if I just use purple, this slope is the leeward slope. Okay, so the direction of current is actually going in this direction here, if you can just see what I've just put on there. So that would indicate the paleocurrent for that sequence from from here probably down to about here is the other bedding plane. So we can see that would be the paleocurrent for that particular sequence there. So that's pretty much it. There's a little tip at the top here. Sedimentary structures, you're usually looking for some sort of photograph or some sort of diagram, so do some research, add into your notes a range of diagrams and photos, look at different questions from previous exams, because they will reuse those different bits of data. And you'll often be asked to work out the geological history, is the sequence the right way up, that sort of thing. And have a look at the other sedimentary structures which I haven't mentioned, because there's lots of them. We'll have a look at an exam question next, so just click on the next slide and the next sequence. Thanks. So welcome back, and this is the exam skills section of sedimentary structures, and you can see at the top I've tried to highlight a key area which would be very, very useful to look at, which is that they often occur alongside other questions. In this case, a fossil question or a relative dating question, which might be to do with the geological history, or which is it the right way up, that sort of thing. So you can see here, we've got figure 2, it's an example question, graptolites, different types of graptolites. So you can imagine that they are going to be asking a question somewhere in the sequence within question 2, it might be question 2b or question 2a, about the graptolites and probably about the age of them, because you can see here, this graptolite at the bottom clearly has one stipe, you know, relatively, you know, simple theca, or lobed theca. So that's probably Monograptus, and there are other ones here, obviously, which we're going to be looking at. So it requires you to have other knowledge to use as well. Now, if we have a little look, you can clearly see the first thing you should be looking at, is it a map or is it a cross-section? Well, it's a roadside rock exposure, which tells you that you're looking at it from the side, and you can see those structures within it. You've got shale and you've got sandstones. So shale, we know, deep marine environment, fine-grained, lots of clay content in there, hence the abundance of these, you know, graptolites in there as well. And look, you can see the P and the Q, they're probably going to ask you to identify those features. Now, looking closely at the sedimentary structure question, because that's the one I've picked out, you can see that it says the strata in figure 2 are overturned. Explain reasons. So you've got to justify your choice that would support this statement. They might phrase it differently about a student has made this statement, but it doesn't really matter. Now, if you were doing that, it's worth 3 marks. So I would be looking for 2 points at the very least to explain why that may be true. Now, sedimentary structures, I think, in this case, are really easy to use. You can clearly see 2 of them here. We've got 2 different structures that you can use. I'm hoping that most people will be able to identify very quickly that the first one over here is graded bedding, and that graded bedding is the wrong way up. It's grading, you know, in this direction. Okay, so the fine is there at the bottom. It should be around the other way. So that's clear evidence that it's the wrong way up. Now, does that support it as well? And what is this sedimentary structure here? Hopefully, you know, you can figure that one out. And I would look for another point as well, maybe related to the fossils, because it will, you know, help your understanding of the situation in this case. Obviously, we have an age here at the bottom. So even if you weren't sure about your corals, they've given you an age, Carboniferous. So if you know your geological timescale, camels often sit down, perhaps not, you know, that order, you can actually start to use that as one of your points. Obviously, you would need to know a little bit about when these lovely graptolites were alive as well, but that could form your 3rd point. So use the data that they've given you, the sedimentary structures there, and write yourself an answer. Once you've done that, have a look at the mark scheme. It's on the next slide, and see how you did. And then go away and find out some more questions related to sedimentary structures, and do some more practice. Do some more revision if you need to. Thanks. Hope you enjoyed.